Good morning. Welcome to math. Today's work is this page called Exploring Prediction. So let's take a look at the quick review to set us up for the page. It says Inga and Ralph conducted an experiment. Inga put 4 green cubes and 11 yellow cubes in a bag. She told Ralph there were 15 cubes in the bag. Ralph picked a cube, recorded its color, then put it back into the bag. He repeated the experiment until he had the results of 30 trials. So he did it 30 times. And here are the results. Well, we've got 10 green and 5, 10, 15, 20 yellow. The results suggest that there are about 2 times as many yellow cubes as green cubes. So Ralph predicts 5 green cubes and 10 yellow cubes. It's a good prediction. Even though it didn't work out in a perfect way, where he got it perfectly correct, he used the results from the experiment to make a smart prediction. So that was kind of an interesting thing to do. It says, suppose Inga put 12 cubes of 2 colors in the bag, and Ralph got these results from 20 trials. What prediction might Ralph make? So we know that there's a bag, and that bag has 12 cubes, right? So if the trial was 20 different trials, and 5 times we had red, and 15 times we had white, well, what would be a good guess for the amount of cubes in the bag? Well, let's see. 15 is 3 more times than 5. So what I'm going to do to try to solve this is, white's a hard one to make. All right, for every red, I guess I'll put in 3 whites, and then I'll see when I get to 12. So I've got a red, a white, a white, a white. That's 4. And I'm going to do that again. A red and a white. I always find it really helpful to draw these models to help me kind of see my thinking and understand. It makes it easier to count. So I've got 8. And let's do another red and a white and a white and a white. So now I have 12 cubes in there. 3 of them are red and 9 of them are white. So that is what my answer is going to be. That's my prediction. The important information that you need to be able to figure out or identify when you're making predictions like this is kind of taking a look at the results from a trial and figuring out maybe how unequal they are and by how much. So when we see 5 red and 15 white, and especially when they're written as tallies, it really makes it easy to see that there are 3 more times white than red. So here's red and there's white. So for every 1 red, there are 3 white. For every 5 red, there are 15 white. So if you can recognize those groups and those groups of 5, maybe that will help you when you're making predictions of what goes in these bags, and see if you can use that information to help you solve these problems. Here's the practice question. It says, predict how many times in 40 tosses a bottle cap will land each way. So a bottle cap has an open side up and an open side down. I want you to predict it. And then it asks you to conduct the experiment and record the results on a tally chart. So you could use a cap from a water bottle. You could use any type of cap. If you can't find a water bottle cap, you could use a lid from a jar even. So that would have a top side and a bottom side. And it wants you to flip it 20 times and keep track. And then write down how your results compare with your predictions. Here it says, look at the spinner below. Predict how many times the pointer will land on each number in 20 spins. So you've got section 1, section 2, and then a large section 3. So you're going to predict how many times the spinner will land on each number in 20 spins. And then it says make a copy of the spinner and use a paperclip and pencil to work the spinner. Conduct the experiment. Record your results on the tally chart. So I just wanted to add one more quick little note. So for this assignment, I have found an online spinner that you can actually make yourself. It's pretty cool. I'm posting this link to this page to the website. So if you want to make the spinner that you need to use for the experiment, here it is. And you're just going to have to do a few things to change it up. So it only has 3 sections. So this arrow here controls the number of sections. And then you can change the sections. So I'm going to make this blue section half, and I'm going to try to get it right at 50%. I'm using this number here. That's with my cyan section. And then I'm going to move this one so I get 2 25% sections. Almost. There we go. So that's a little bit finicky and tricky, but once you get them set up, you're all set. And it automatically calculates the probability. So the theoretical percentage, we haven't talked about these fancy words yet. They're more like a grade 6, 7 level. But this is what you'd expect to happen. So this is actually the answer for the stretch your thinking part of the page. And the experimental percentage will be what happens when we try it. So I can spin it, and I know the exercise asks us to spin it 20 times. So I'm just going to spin it maybe 10 times on my example. And it keeps track. Over here on the table below, looks like I've done 8 spins. There's 9, and there's 10. And it's really interesting because in my experiment, you'd think that it would land in the cyan section more often, but only 20% in the cyan section, only 2 times out of 10. 2 times out of 10, it was in the yellow, and it just kept landing in this blue section for some reason. So I wonder if I continued my experiment all the way to 20 trials, what I would get. And I'm going to do that just because I'm really interested to see if we start getting more spins in the big cyan section, because that's what is expected. The idea with probability is the more trials you run, the closer your experimental percentage is going to match up with your theoretical percentage. So far in this experiment, it's just not happening that way. And that's okay too, because when you're talking about probability, unless you're talking about something that is certain, then it's not certain. So even if you have a 1% chance of this spinner landing in a section, it could land in that section 100 times in a row, and the chances of that happening would be crazy low, but it could possibly happen. So here after 20 spins, this would be the data I'd have, and I could put that in my table in the question. So that might be a fun way to conduct this experiment.